Now, on the next page, we have another topic called fractional exponents. Fractional exponents. Did everybody bring their calculator today? I hope, because we're going to need the calculators. We're going to need the calculators, and you're going to need this calculator also. The one between your ears and also the one in your hand. Let me start with a problem like 9 to the 1/2 power. Have you ever seen a 9 to the 1/2 power before? Now you know what 9 to the first power is, don't you? 9 is just 9. Okay, 9 to the first power is 9. You all know what 9 to the second power is. That's 81. You know what 9 to the 0 power is? 1, okay. And you know what 9 to the -1 power is, don't you? 1 over 9. Remember, a negative exponent means 1 over. Quick review, no extra charge there. But 9 to the 1/2 power. You can't really say that it's 9 times itself 1/2 time, can you? Like you do up here. 9 times itself gives you 81. You can't say it's 9 times itself 1/2 time. We just don't know what it is. So let's let it equal some unknown number. Let's let it equal x or y or something like that. Now, what I want to do is try to find out what that value of x is. One way I can find that value of x is to say it's going to be somewhere between 1 and 9, right? In other words, if 9 to the 0 gives you 1, and 9 to the 1 gives you 9, and 9 to the second gives you 81, you could figure that 9 to the 1/2 is going to be somewhere between 1 and 9, right? Because the power is between 0 and 1, therefore the value will be between 1 and 9. So let me write this down. 9 to the 1/2 is equal to x. And in order to try to get some understanding of what this is, I'd like to raise both sides of this equation to the second power. Raise both sides to the second power. Now you remember what you do when with the laws of exponents, when you have a power raised to a power. Anytime you have a power raised to a power, what do? You multiply exponents. So that would give you what? 9? That would give you 9. Is equal to x squared. Okay, that means that x squared is 9. Now what can you square and get 9? Actually, there are two things you can square and get 9, aren't there? 3 and also -3. We're going to call that actually plus or minus 3. But remember, we're looking for a number that's supposed to be between 1 and 9, and I want to have just one answer for this thing anyway. So what would it be? Positive 3. So in other words, we're saying that here x equals 3. Okay? So in other words, 9 to the 1/2 power is 3. Because that's what x is. This x right here is that x. So in other words, 9 to the 1/2 is 3. Now what operation did you have to go through in order to get the 1/2 power? What operation did we do to get x? You had to do square root, didn't you? Yeah. Okay, in other words, what we just showed here is that 9 to the 1/2 power means the square root of x, the square root of 9. So let me give you another problem. What would be 25 to the 1/2 power? If I just said 9 to the 1/2, and what I have to do is do the square root of 9 to get 3, what would be 25 to the 1/2? 5. Okay? It would be the square root of 25, let me write it down, the square root of 25, which would be 5. Okay? What would be 144 to the 1/2 power? What would that mean? Square root of 144, which would be 12. Okay? All right? Now, can you do that with a calculator as well?
Sure.
Do you have raising to a power? Now you already know that if you do the square root, we all know how to do square root of 9 with the calculator. You know, you just enter 9 and hit the square root button and there it is. Okay? Now what I'd like you to do is try 9x to the y power, do 9, and then with your calculator, x to the y power, or maybe it says y to the x power. And by the way, what is 1/2? 0.5. Now give it a 0.5 for the power. 9 raised to the power of 0.5. And equals, what would it be? 3. Okay? Any questions on that? So there, you can use the calculator you can use the calculator in your head as well. Now, if the 1/2 power means square root, if the 1/2 power means square root, in other words, if I said x to the 1/2 power, that means the square root of x, then can you tell me what it would be if I had, let's say, x to the 1/3 power? If the 1/2 power means the square root, then the 1/3 power means the cube root of x, okay? The cube root. So if I said 27 to the 1/3 power, that would be asking you for the cube root of 27, which would be 3, okay? What if I said 16, another number, 16 raised to the 1/4 power? Any guesses what the 1/4 power would be? 4th root of 16. And what's the 4th root of 16? 2. And how do you know it's 2? Because 2 to the 4th power, 2 times 2 times 2 times 2 would be 16. Okay? And what if I said 32 to the 1/5 power? Any guesses on that? The 1/5 power? 2. It would mean the 5th root of 32, which would be 2. Okay? All right, let me give a generalization then. If I had, let's say, x to the 1/n power, then what would you have to do to x? Do the n root of x. X to the 1/n would be the n root of x. Okay? Now, as a second thought, what would it mean if I had something like 27 to the 2/3 power? 27 to the 2/3 power instead of the 1/3 power. Now you see, we understand what 1/2, 1/3, 1/4, the 2/3 power, what it really means is to take 27 to the 1/3 power and then take that squared, you see? Because when you raise a power to a power, you multiply exponents. In other words, what this means, if you take 27 to the 2/3 power, the 3 gives you the denominator, and that becomes the root. The 3 root, the cube root of 27, let's say that the base number is 27. And then I'm going to raise it to the 2nd power. So it's going to be that quantity raised to the 2nd power. All right, what would you have for an answer? The square root, the cube root of 27 would be 3. 3 squared would be 9. So the answer comes out 9. Okay? Any question on that? Let me give you a couple more examples to go with that. All right? Suppose I had 9 raised to the 3 halves power. Colorful problem, right? 9 raised to the 3 halves power. What is the 9? That's the base number. I forgot to tell you what the 9 is. The 9 is called the base number. So I'm going to have 9. What am I going to have to do to the 9? Square. I'm going to have to... Now don't say square it. You'll have to square root. Square root the 9. You don't have to put the little 2 there now, do you? And then we're going to do what with the 3? Raise it to the 3rd power. Okay? So the base number, the root of the denominator, raised to the power of the numerator. So that means take the square root of 9, which is what? 3. And then 3 raised to the 3rd power would be 27. Okay? Now I'd like you to try that with your calculator. Can you do that with a calculator? First of all, does everybody know what 3 halves means as a decimal? 3 halves means what? 1.5. Can you see that 3 halves? Now, the 1 and 1/2, which is 1.5. So use your calculator to get 9 raised to the 1.5 power. Can you see that that's this right here? This power is the 1.5 power. Okay? And do the calculator Do the calculator. 9 raised to the 1.5 power. Did it come out 27?
Yeah.
Okay. All right. 27. Okay. Now, I got another question. What if it's a number you don't recognize? Just off the top of your head, you probably all recognize that 3/2 is 1.5. What if you didn't recognize that? Now, do you have on your calculator a special button called the A raised to the B over C? Let me leave these two examples on the board. A calculator button that says A raised to the B over C button. A lot of calculators have that button on it. And if you have that button, let me show you how to enter this number. What you do, if you wanted to do A to the B over C power, you want to do 9 to the 3/2 power. 9 to the 3/2. I think I will clear the board. 9 to the 3/2 power using that special button on the calculator. You'll enter the 9 first. Enter 9. And then you'll have to do y to the x power, or x to the y power. And then enter the numerator of the exponent, which would be 3. Give the numerator 3 to the calculator. And then next would be that A raised to the B over C button, if you have such a button on your calculator. And then what happens is in the calculator it says this. It says 3, and then there'll be a little, this kind of a symbol. Okay? And then you enter the denominator power, which would be the 2. Enter the 2. Okay? And then the calculator says 2. 3, whatever the symbol is, 2. And then equals. And what does it give you? 27. Okay? So there you've got 2 ways to do all of these problems. I don't want anybody to miss a problem on this section, because you've got 2 different ways. I want you to be able to do it both ways. Remember, on the Florida class, you're not allowed to use a calculator. So it would be nice to be able to do these things without a calculator. On the other hand, it's a tool of the trade, so it's nice to be able to use the tools of the trade. Okay? Now, another example that I'd like to try is something like 16 to the 3/4 power. 16 to the 3/4 power. Let's try it using the A to the B over C button. What numbers do we enter? 16. And then we'll do the x to the y power, because we're raising 16 to the power, or it'll be x to the y or y to the x power, whichever your calculator says. And then you enter the numerator, which would be what? 3. And then you do the A to the B over C button. Then you enter what? 4. Okay. Enter 4. And then what? Equals?
8.
And it comes out to 8. Okay? Does that sound right to you? Now let's do it the other way. Let's do it without the calculator to see if it still comes out to 8. What does 16 to the 3/4 power mean? Take 16, and then what do we do with 16?
Raise the 4th.
Right, the 4 represents the 4th root. So we're going to take the 4th root of 16, and then we're going to raise that to the 3rd power. In other words, we take the answer you get for the 4th root and cube it. Okay? Now, what would that be? 2 cubed. 2, and then cube it, which would be 8. Okay? Any question on that? All right? Now, here's a formula then that I'd like to put with this other formula. This formula says x to the 1 over n, and now let me write this as x to the m over n power. X raised to the m over n power. First of all, we'll start with a base number. What's the base number? X. Put that down. Now, what are we going to do with the x? N root of x. And then we're going to raise that to the m power. The numerator gives you the power. The denominator gives you the root. Okay? Hey, I got another thought here. Would it also be possible to write this as the nth root of x to the m power. Do you see that? Do you think there'd be a difference in this? Is there a difference in notation here? Here you see I'm doing the root first and then raising to the power. What's the order of what I'm doing here? Raising to the power of the numerator, and then I'm doing the root. First, we did the root first, and then we did raising to the power. Now, just between you and me, that's the best way to do it, isn't it? But let's try taking a look at this. What if I did it this way by saying, let's take the fourth root of 16 cubed. In other words, let's start with the 16 and cube it. Take your calculator and take 16 and cube it. That means 16 x to the y power 3. Okay? What did it give you?
4,096.
4,096. Okay? And that would be the fourth root of 4096. Now what you'd have to do would be use your calculator to take the fourth root of 4096. Do you remember how to do raising to the fourth do you remember how to do a fourth root on the calculator? Did we do that earlier in this session? What we'd have to do would be, remember you've got this inverse, the second function button? And what you'd have to do would be, say, 4096, and then you'll have to do the second function, or the inverse function, and then you'll do the y to the x power. Now you see, that's because this button that we want to do is actually right above, the button says y to the x, but what you want is the x root of y. So in order to get off the button to do the fourth root, so we start with 4096, then we do second function, and then we hit y to the x power, and then you have to tell it what root you want to do. What root are we doing here? Fourth root? So you give it a 4, and then equals. And what does it give you? 8. Okay? Which is the easiest way? I've shown you 3 different ways to do this problem. That's probably the hardest way, isn't it? Probably the first way is the easiest, using that A to the B over C button. Or maybe, I want you to really understand this concept that we take the root of the denominator, raise it to the power of the numerator. That's what I really want. Okay. Now, what if I had something like, 8 to the negative 2/3 power? I'd like to do 8 to the this is number 19, I think, isn't it? Number 19?
Yeah.
Number 19, it's on page 102, 8 to the negative 2/3 power. 8 to the negative 2/3 power. All right? There are 2 ways to do this one. At least 2 ways to do this one, maybe more. Let's start with the way that I want you to do it in your head first, and then we'll get to the calculator. I know some of you are already doing it with a calculator, but let me do it in your head first. With no calculators, what root do we do? The cube root of the base number 8 raised to the negative 2 power, right? Okay, so what's the cube root of 8? 2. So that would be 2, and 2 raised to the negative 2 power. Now what is 2 to the negative 2? 1 over 2 to the positive 2, which would be 1/4. Okay, 1/4. Any question on that? That's the main way to do it. All right, now let's try it with a negative exponent. Use the calculator. Now, do you like that A to the B over C button? You don't have one. Okay, now if you don't have an A to the B over C button, then what you'd have to do would be find out the decimal value of this thing, which is, well, 2/3 is what? 0.66? By the way, if you use 0.66, is that good enough, or is that kind of rounded off? I think we'll need to use a little more accuracy. Use 0.666666666. Carry out the 6. And that's going to be the power, but it's going to be negative, isn't it? So you could write that as 8 raised to the negative 0.666666 power, and so forth. Give it as many 6 as you can. And let's try it that way. What I do is I'd start with 8, and then I'd do x to the y power, or y to the x power. And then I'd give it, now, some of the calculators you can enter negative 0.66666. Some of the calculators you'll have to give it the 0.66666 number, and then you'll have to hit that plus or minus key. Hit the plus or minus key, plus or minus key, in order to change it to a minus 0.66666. And then equals. How does that do? Does that work? I hope it doesn't give you 0.
Gives me 0.250000.
0.25? 0.25. He gets an answer of 0.25.
That's the right answer.
What do you think about 0.25, folks?
Interesting.
That's what 1/4 is, isn't it? The calculator's not going to give you 1/4, is it? The calculator's going to give you the decimal equivalent. So if you work it out in your head, you're probably going to get a fraction, in which case I'd leave it in a fraction. If you work it out in the calculator, you probably get a decimal, in which case I'd leave it as a decimal. That's fine. Now, for those of you that have the A to the B over C button, this is going to be cleaner. Let's do it with the A to the B over C button. Start with 8, and then do x to the y power, or y to the x. Then you have to enter the numerator exponent, which is, 2. And then you probably will, do you do the plus or minus button next?
Yeah.
Yes.
Go ahead and, I think you can put the plus or minus in there.
You could do it at the end.
I think you can put
This
the,
one you have to do it at the end.
with some calculators you have to do it at the end.
Yeah.
Okay, let's save it till the end then, thank you. Save me on that one, because I'm not really sure. This is where you'll have to experiment with your particular calculator. But if you'll do 2, and then A to the B over C button, and then 3, and then do the plus or minus key, plus or minus. Now it says negative 2/3, or,
Yeah.
okay, and then equals 0.25, right? 0.25,
Right on.
right? Any questions on that? All right, that's clear? All right? Now just remember, anytime you have a negative exponent does not make the answer negative. A negative exponent makes the fraction 1/, something. Okay? Now I think that will take care of the explanation that you need to get you over to page 103. And then we have another very important idea. We're going to now have to talk about what if the base number is negative. What if the base number is negative? For example, what if you had -1 and we try to take the square root of -1? And then what if we try to take the cube root of -1? Are these the